Welcome back to my channel, everyone. Three tips here. What I have here is a bag of gold filled material. This is about 7 months worth of accumulation, and last time I did this was about 7 months ago. So what we're going to do is we're going to dump this out and go through all this material and clean it all up and get it ready to recover the pure gold from this gold-filled material. See, I had a nice, there it is, it's a Bulova Accutron. It's running. It makes a humming noise from the movement. It's got the correct time on it. And I put a battery in it and it took off, so we'll offer this for sale separately on the eBay store. So what I'm going to do now is get down in here, clean all the non-gold filled material off of this stuff. I've got the material cleaned up, and what we'll do is bring it over here to our ultrasonic cleaner. And this really isn't necessary. I'm just doing it because I have the ultrasonic cleaner. I'm just going to run some of this through a batch at a time and try to get some of the dirt that's on this stuff rinsed off of the gold filled material. Now let's bring this up over here to the steam cleaner and give this a steaming. I've got the gold filled material cleaned up, allowed it to dry and then cool completely. I'm going to throw this in a weigh boat and check the weight of our material. So it looks like we've got 603.9 grams, 603.9 times 0.025, 2.5%. So we should be looking at recovering about half an ounce, 15 grams of pure gold from this gold filled material. I'm going to do the reaction in a 4-liter beaker. I'm adding about 3/4 of a liter of distilled water. Now, even though it's probably not necessary, we're going to take our clean gold filled material and we're going to hit it with some flame. Now what we're going to do is start dissolving out the base metals out of the gold-filled scrap. I'm adding some nitric acid here. It's about 200 milliliters of nitric acid just to get this thing started. It's been about 10 minutes since I added the nitric. I'm going to add another small dose in here. Keep things moving. And then now what I'll do is I've got a separatory funnel here. It's got a little delivery tube on the bottom of it. Got the valve shut. So what we're going to do now is fill this up with nitric acid and then drip it in real slow. I'm going to put this lid on while we insert the device into the fume hood. Just gonna stick it in here like this. Now we'll stick the delivery tube into the beaker. I'm gonna reach up here, get the lid off of this thing so that we don't get a vapor lock. Now we're going to turn on some acid flow down into our reaction beaker. Cut that back just a little bit. Just want to drip it in real slow. Still a little quick. There we go. Just so it's a drip. Got that first bottle of nitric in there. I'm going to crank the heat up a little bit. Let's turn the valve off. And then we'll pull this down and get this thing out of here right now and refill. Got the heat cranked up on high, and we're slowly delivering the nitric charge through our separatory funnel. The goal here is to get the nitric acid in on the gold filled material as quickly as possible and as safely as possible without creating a boil over. Gold-filled material is a thick coating of gold over a base metal, usually brass. Brass is an alloy of about 85% copper and 15% zinc. Both of those metals are soluble in nitric acid. So what we're doing is adding the nitric acid, dissolving out the brass, and we'll leave the gold foils behind. Then we can recover those gold foils and refine them into high purity gold. Our solution has been boiling all night long. You can see the amount of liquid has boiled down considerably. What I've been doing is coming out and checking on it just to make sure that we didn't boil it all the way down to dryness. And the time right now is about 6:30 in the morning, and I added that acid last night about 10 p.m. I think we're complete. Now I'm going to pull this down off the heat. Let's get in here and have a look and see exactly what it is we've got going on in this beaker. Stick a glass rod down in here and take a look at the material that's left. Oh yeah, look at that. I think we've got every bit of the base metals to dissolve completely. So what I'll do now is I'm going to add let's see here, add some distilled water to cool this down and to dilute the solution. I've allowed this to settle completely. Now what we're going to do is we're going to draw off the solution with a vacuum bottle out of this our reaction beaker. We're going to draw the liquid off. Here's a look at the material that we've recovered from our gold-filled scrap. Now what I'll do is add some distilled water and stir this up real good. I'm going to try to rinse some more of that blue liquid off of here. Here's a look at the material down in there now. Got all the material transferred into this smaller beaker, and now we'll put it up here on some heat and let it boil in distilled water. It's a piece of copper from my silver cementation bucket. Now what we'll do is add the solution that we just drew off from our gold-filled scrap. We're going to cement out any precious metals that's in this solution onto that copper. There's probably going to be a lot of excess nitric in here, so it'll consume this copper rather quickly. Here you can see there's an immediate reaction. There's silver starting to come out of solution on the copper. But as I said, there's probably going to be a goodly amount of excess nitric acid in here. It'll chew that copper up rather quickly, and I'll probably need to put some more copper in here in a few minutes once all that copper gets consumed. Here's our jar that we're cementing the silver out on copper. You can see the silver in there is accumulating in the bottom of our beaker down here. What I'll do is turn this off now. We'll let this cool down and then go from here. I've got our solids down in the bottom of this 2-liter beaker. I've boiled it in distilled water. And what we're going to do now, there's probably going to be some silver in here. So we want to move it into this jar and cement the silver out. The silver has been cemented out of this solution for the most part. So now what we'll do is I'll transfer some of this solution out of this beaker that we've used to cement the silver out down into my silver refining stock pot. This has got pieces of copper in it. I put all my copper nitrate waste in here that's had all the silver removed out of it. But just in case there's any precious metals remaining in here, I transfer it from here into my silver refining stock pot. Now what we'll do is move the cementation beaker. It's got our copper in it. Set it down low down here. And we'll bring up our solution here that's going to have a little silver into it. And now what we'll do is we'll siphon the liquid out of our gold-filled solids that we recovered. That's boiling distilled water. I'm going to siphon this solution that's going to contain some silver down into our cementation beaker now. Filter the solids out of our beaker. I've got a specially prepared filter paper here, and this is to ensure that I capture 100% of the solids from our gold-filled scrap that we've recovered. Now we're going to add this material to this filter. Try to filter out these solids. There we go. Got all the liquid pulled through the filter now. We've got our gold-filled material in the gold mud down here in our filter. Let's put it up here out of the way for a second. And what we'll do is I'll add the blue liquid. Might have a little bit of silver in it. So we'll add this to our beaker over here with some copper in it. Cement out any precious metals that might be in this solution right here onto the copper in this beaker. Here's our prize in this funnel in this filter. It's our gold filled material. Should have all the silver and base metals removed from it now. We're going to take it, we're going to put it down here in this melt dish. Now we're going to take our filter with our gold filled material, put it in the furnace, and incinerate this. We've had this stuff heating up for about 25 minutes now. It's up around 1500 degrees Fahrenheit. So now what we'll do, we're gonna get in here, take a look at it. Oh yeah, it's nice and red. We've got it heated to redness. Now we're gonna take this in and process it further. I'll let it cool off for a few minutes, and then we'll go to the next step. I've allowed this to cool completely. Here's our incinerated gold foils and mud. All the paper and everything has been burnt away. Normally what I do at this time is dissolve this material in aqua regia, but instead I think we're going to try a different route this time. What I'll do is let me get a weight on this stuff. Alright, we've got 42.8 grams. To calculate how much I need to inquart this metal, these foils, I've got an estimated 15 grams I'm expecting from this. It's probably going to be more. It's probably going to be more like 18, but we'll use 15. So I want an alloy that's 25% gold and 75% silver and base metals. So I multiply the amount of gold that I'm expecting by 3, and I get 45 grams. 25% plus 75% equals 100%. I've got 42.8 grams of gold foils. I've estimated that there's 15 grams of pure gold in here. So now what I need to do is take 42.8, subtract out the 15 grams of gold, and that gives me 27.8 grams. Actually, this is 27.8 grams of other metals that are in here. I need to add 45. So now what we do is we take 45 from 27.8. 45 minus 27.8. That leaves us with 17.2 grams of sterling silver that I need to add to this material in order to create a 25% gold alloy alloyed with 75% of other metals. Looks like I'm going to need 17.2 grams of sterling. I've got some pieces of sterling silver right here, and they're going to weigh 21.3. So I'm about 3 grams, 4 grams over what I calculated. And the reason I'm doing that is because this estimated 15 grams is probably going to be closer to 18 grams. So now we'll take this out and melt this up and quart these gold foils on the melt table.
I'm slowly running out of oxygen.
My oxygen bottle ran out, so I had to swap the tanks. Now we're going to continue to melt. This particular kind of scrap does not like to melt and go molten. And so I had to go in and grab some more pieces of sterling silver to act as a collector metal to get the rest of this stuff to melt, to go molten. And we're going to end up with too much silver in this now. I didn't get a chance to stir this up to make sure I got a good alloy. Here's our button of metal. I'm going to remelt it now. And then we're going to stir it with a graphite rod just to make sure we've got a consistent alloy. Here's the inquarted gold foils. What we're going to do is start pulling the silver and the base metals out with dilute nitric acid boils. This is dilute nitric acid used in a previous refining. So what this will do is the gold is not very soluble in nitric acid, but all the base metals and all the silver that we've added is highly soluble in nitric acid. So we're going to boil away the silver and the base metals that are in this alloy right here, and it will leave behind the pure gold. I'm going to put this up on the heat and start adding some heat. Let's take it down off the heat now. Now what we'll do is just let this material settle out. You can see it's got a lot of powder in it. It's going to take a while to settle. Allow this to cool off a little bit and settle out. Now what we're going to do is I've got a filter set up here, and we're going to try to filter off this liquid and capture the solids that's suspended in this liquid. Alright, here's what our solids look like down in the beaker. Now let's continue to pull the silver and the base metals out of here. I'll add a little bit more nitric acid. Here's some fresh nitric acid. A little bit of water. Using distilled water here. Cover this up. Gotta set it back up here on the heat and let that nitric acid continue to pull silver and base metals out of there. The solution's not heating well in here. It's popping. So what we're going to do is transfer our solution up onto this not taller, but up onto this other burner. It's spattering as it's heating, so I'm going to add a stir bar. I'm going to add some stirring as we heat this up. I don't see any more fumes being produced. Let's turn our stir bar off, turn the heat off. I'll reach under here and get the stir bar out of here. Get it up out of the way. We're going to set this down and let it cool off. This is what happens when we add too much silver to the gold. It crumbles and falls apart into a powder, and we have to wait and allow it to settle completely before we can separate the silver bearing solution from the gold powder. Properly inquarted gold, we can just pour that blue solution off of there and keep going, but when it falls apart to a powder like this, it takes longer. I've allowed this to settle for about half an hour. Now what we'll do, this is our solution. I'm going to pour it off into a filter here and try to capture any solids that might be in this liquid. This liquid will be full of silver. Here's our gold down in the bottom of the beaker. I think what we'll do is, since we're still seeing blue color, add some water here. I'm going to set this back up on the heat. I'm going to do one more nitric acid boil. Nitric acid. Turn that stir bar on and let it go. This one's been on boiling now for about half an hour. Let's take it down off the heat and let this cool off. I think we've got all of the soluble metals to go into solution here now. I think what we'll do is just here's our gold down in here. Pretty sure we've got all the silver and the base metals dissolved out. I'm just going to give this a boil in some distilled water now without any acid. This has been on boiling now for about half an hour. Let's get our stir bar out of here. I'm going to set this down now and let this cool off. We're going to rinse down the inside of the beaker. I've allowed the gold to cool and settle out completely. You can see here that the solution is nice and clear, colorless. So what we're going to do now is I'm going to draw a sample of this distilled water that we boiled the gold in into this small beaker. And I want to test for the presence of silver in here. So we'll add a little bit of hydrochloric acid. If there's silver present in this solution, we'll get a white cloud of silver chloride forming. And there you can see there's still plenty of silver in this solution. I think all the silver and base metals have been removed from the gold. Now we just got to get it rinsed off and get that solution off of there. So now what I'll do is I've got a vacuum bottle set up. We'll connect this vacuum bottle to my vacuum source. We'll do another rinse with some distilled water. Put it back up on the heat. Just keep doing this over and over until we got all the distilled or all the silver rinsed out of the gold. This is the silver that we cemented out on copper. I had some other silver solutions sitting around my shop. So all this silver is not from this refining of the gold filled material. I added some additional pieces of, I added some additional silver nitrate solutions in here to get them to cement out. There's the copper. So I could recover the silver from those other solutions. Right now what I'm going to do is break this up and let this settle out, and then what we'll do is siphon off the blue liquid into my silver refining stock pot so we can make some room in here, because what I'll be doing is adding this solution. It's going to contain a lot of silver to this beaker that has copper in it to recover the silver from this silver solution. I got 2 more water boils done. This one's cooled off and been sitting here about an hour, and it's not settling out, staying suspended. So we probably should have just went ahead and dissolved the gold foils way back earlier in the video. I'm going to add this. Going to have a little bit of gold in it. put this in this beaker now. This is just water in here. There's probably going to be some silver left in here. So be it. We're going to add hydrochloric acid up to about the 500 milliliter level. Now what I'll do is add some sulfuric acid. I will cover this up, set it up on the heat, start stirring. I will add small doses of nitric acid and get this gold to go in solution. It's 3 milliliters. We'll start out with that and go from here. I've had this on for several hours. I've evaporated it down to about half of its original volume. I'm going to pull this down off the heat now. And what I do want to do is get that stir bar up out of there. I'm going to set this down, let it cool off. Now we'll add some ice to cool this down. I've been filtering for about 2.5 hours. I've just got rinse water in here, so there's not going to be very much gold. I'm going to take this out of here now, and I'm going to just get it out of the way. Continue to pull any liquid that's in here out of this. Right now what we're going to do is transfer our solution into this beaker. Let's do our first precipitation. We've got sodium metabisulfite here. I'm going to add a couple of spoons of this and precipitate out the pure gold. Here we go. I've allowed the gold to settle completely. And now what we'll do is we'll pour off this waste solution. Our gold powder is very fine. It takes a while to settle in here. After each of these rinses, I've given it a couple of rinses with distilled water. And now what we're going to do is I'm going to add some hydrochloric acid to the gold. There it is. It's a respectable amount too. Add some hydrochloric acid, And we're going to put it up on the heat and let this boil in hydrochloric acid for a few minutes. There are some refiners who say that hydrochloric acid boils like this are not necessary. They add an extra step, but I don't care what anyone says. I believe that these hydrochloric acid boils clean the gold up nicely. I've had the gold on boiling now for about 10 minutes. Hydrochloric acid. What we're going to do is we're going to take it down off of the heat. I'm going to allow this to settle out, cool off. Let's see if I can tilt this thing. Yeah, there we go. That'll help settle when we go to pour it off. We don't pour off a bunch of gold with the waste solution. That hydrochloric acid boil cleaned the gold up nicely for us. Now what we'll do is let's go ahead and pour this waste solution off. And look at that gold down in there now. Starting to look like pure gold. I'm going to give this a couple of rinses with some hydrochloric acid and then some plain water. I've rinsed it off several times with cold hydrochloric acid and some water. What we're going to do now is I'm going to add about 100 milliliters, 150 milliliters of hydrochloric acid. I'm going to set it up on the heat up here and redissolve it a second time. I'm adding some sulfuric acid to take care of any lead that may have made it this far into the process. Now we're going to add some nitric acid. I'm going to add about, well, let's start out with 1 3 milliliter squirt of nitric acid. I'm adding another shot, 3 milliliters of nitric acid. It's been dissolving for about 15 minutes now. And if you look, we still got quite a bit of undissolved gold down in the bottom of this beaker. And the reaction is slowing somewhat. So I think what we're going to do is we're going to add just a little bit more nitric here. Let's make it another, that's about 2 milliliters of nitric acid going in. Hopefully this will be enough to get the rest of this gold to dissolve completely. If you look down in there, see that the gold is kind of dancing in there from the reaction. the gases being given off cause those chunks of gold to begin to float like they are right there. That means we're getting pretty close to having everything go into solution completely. This took about a half an hour. I've got all the gold to dissolve. I boiled it on high or near high until all the fumes were gone. And we're going to pull this down off the heat and let this cool down. Now we'll add some ice to this to help cool it down, dilute it, and precipitate out any silver chloride that may be present. Let's run it back through the same filter a second time. Starting to clear up. We're going to put it back through the same filter a third time. It's getting clearer every time we do this. Particulate is being filtered out. Here's the junk that we filtered out of this second refining. Now what I'll do is I'm going to continue to rinse this filter down into a separate flask. I don't want any of the contamination rinsed down into our main solution. Nice and clear now. We've got all the solid material filtered out of here. Do a quick test with stannous. Get a little bit of this solution on a piece of filter paper. Make sure we got gold in solution. And there you can see by that dark stain, definitely got some gold in solution. I've got some reagent grade ferrous sulfate from a previous precipitation. So what we're going to do is we're going to go ahead and add this ferrous sulfate to our gold solution and precipitate out the gold with ferrous sulfate. Here we go. I'm getting some gold to form on the side of the beaker there. Let me stir this up by swirling it around a little bit. This only took about 20 minutes to settle. Looks just like gold in solution, ferrous sulfate does. But you can see by this test that all the gold has been precipitated. Let's go ahead and pour this solution that we pulled through that filter. It's going to contain a little gold, so we'll add it to our gold refining waste container. Now we'll pour off the waste from this beaker, and we'll get our pure gold that's settled out down on the bottom of this beaker. Alright, now what we'll do is we'll add some hydrochloric acid, put it up on the heat, and give this a boil in hydrochloric acid. Alright, we've had it in here boiling now for about 10 minutes. Take it down off the heat, let it cool down a little bit. Now let's get rid of this waste solution. Pour it off into our waste container up here. Let's go ahead and get the gold down into a melt dish. Now we'll take it over, melt it, and pour us a nice little ingot. It's got a skin forming on it. Try to flux a little bit of that off. I've got some potassium nitrate. Get the gold real hot. And then add that potassium nitrate. Try to get the junk off of there. When we do this, the contamination flows to the top of the molten gold. And then combines with the extra oxygen in the potassium nitrate and burns off. The only problem is some of the gold burns off too. Now we're going to hit it with some borax. A little pinch of potassium nitrate on there. A little bit more borax. Let's go ahead and try to pour this into an ingot now. There we go. And you can see there's some junk on there on the surface. It's got a frosty appearance. But at least we'll be able to get a yield on this now. Here's our gold ingot. You can tell it's got a little frost on it. That's contamination in there. And what did we have? I think we had 6. Let's see what the weight is. 21.5 grams. So the yield on that scrap was 21.5 divided by, what was it, 603.9. So the yield was about 3.5%. And that's normal for gold-filled scrap. I used 2.5%, but there may have been some carat stuff in there connected to the gold-filled material, and that's what raises the yield. So we've got a small gold ingot here. Best way to go, proceed with this is to inquart it with silver and do another complete refining on it, but we're not going to do that in this video. We've got 21.5 grams of 99% pure gold. This was a difficult refine. It took me a week and a half to get this complete. Probably would have been better to just take those gold foils after I incinerated and dissolve it in aqua regia and proceed from there rather than inquarting with silver. That was an experiment to see how it went. It was a fail. I'll call it a fail. But it shows what not to do. What we'll do is we'll put this watch on my eBay site for sale. It's a Bulova Accutron. It does work. It hums as it operates. Hold it up to your ear and you get a nice humming sound to it. So we'll put this on the eBay site and offer that for sale. And well, that'll conclude the video. I'd like to thank everyone for watching.